Okay, sorry for the interruption, but I was going on at some length. Yeah, this deserves length. Okay, so back to slope equals rise over run. Okay. Okay, rise over run between what 2 points? Somebody said, well, between the origin and the midpoint. Perfectly valid. Rise would then be 18 centimeters per second. The run would be 1.5 seconds. You could alternatively do that between the origin and the final point, which would give you a rise of 36 centimeters per second and a run of 3 seconds. Now, the calculation comes out very easily. You get 12 centimeters per second squared, and that is the slope of your v versus t graph. That is the acceleration. Why is that the acceleration? Okay, well, I want to talk a little bit more about why that's the acceleration. So I asked, okay, well, what would you call the 36 centimeters per second and the 3 seconds? And somebody said, well, in terms of the motion of the particle, that would be the final velocity. So we divide the final velocity by the time interval, and that gives us our acceleration. Well, that's not right. I mean, it does work here. It does work for this interval, and it also works for the interval from 0 to 1.5 seconds. Final velocity would be 18 centimeters per second, and the run, the change in the time, would be 1.5 seconds. However, it should also be true for this interval, from 1.5 seconds to 3 seconds, because we still have the same slope, we still have the same acceleration, but the final velocity here is 36 centimeters per second, and the run is only 1.5 seconds. And that's not going to give you the same acceleration. So there's something wrong with final velocity divided by the time interval. Or even worse, final velocity divided by the last time. So what is the actual calculation? Well, what's the definition of acceleration? Average acceleration is change in velocity divided by change in time. Nobody said change in anything, just said final velocity divided by time. Well, it works for this interval, it works for this interval, but it doesn't work for this interval. It's the change in velocity. And why does the rise over the run give you change in velocity over change in time? Well, the rise between any 2 points of the graph would be the change in the velocity. The run equals change in time. So the slope is change in velocity over change in time, which equals average acceleration. You got to lock that in. You got to understand that in terms of this graph. Also, this is average acceleration. And since we're talking about acceleration in the x direction, I'll put the sub x on there to continue distinguishing this from this and remind you that you need to. In this situation, the acceleration is always the same. So in this situation, that is the acceleration. Okay? Okay, so I then asked people to calculate to draw the graph, label it, do all the calculations, represent everything, understand what everything means for this ramp and for this ramp. And people appear to have done that pretty accurately. We'll go on and talk about that and what we get out of that exercise.